to Daniel Lockhart, working at Key Free Technologies, and yeah, I'm here to present to you on serverless, explaining what serverless is as a paradigm, and on how you could use and deploy Go functions on AWS Lambda, which is something only recently you were able to do officially. So, what does serverless mean? Serverless generally refers to functions as a service, which is most popularized by AWS Lambda, I don't know, maybe 4 years ago, when they kind of allowed you to just take JavaScript code, send it up to their servers, and just kind of run it without caring about, I don't know, installing Node.js somewhere, or caring about the underlying operating system or anything really. That's what serverless is usually taking to mean, but serverless also refers to using platforms as a service, referred to as PaaS, and this is things like, you know, managed message queues like AWS SQS, you know, Azure messaging, or managed databases in the cloud. Even something like Postgres using AWS RDS can really fit under the wide banner of serverless, because what serverless is focusing on abstracting away server management and capacity planning. You're simply trying to distill the business logic of your code into as little, I don't know, you're trying to distill the business logic of your code away from all of the infrastructure headache in terms of setting up servers and, you know, managing with any scaling things, anything like logging, anything like monitoring. That's what serverless really is, just trying to abstract away all of that. So yeah, spend less to no time managing infrastructure, trusting your service provider instead. Trusting is a imperative word in that sense. So, why would you use serverless? The pros. Pay-as-you-go pricing model saves costs. AWS Lambda, for example, is built to the 100th millisecond, which means that if you have a function that's only going to be running for, you know, 10 seconds, an hour, whatever, you're only going to have to pay for how much time it takes to run that function on their servers. You don't have to pay any more than 100 milliseconds over. Scaling up and down effortlessly and automatically. A benefit of not having to deal with servers is not having to deal with provisioning more and provisioning less when, you know, things go wrong or customer demand scales up. AWS Lambda in particular is simply just running each one of your functions in a new container for every request. So yeah, it's pretty good at scaling to meet demand. Iterate quickly during development, focusing on writing code rather than infrastructure. Yeah, so I mean, this applies to the Node.js form of AWS Lambda more than Go, but like AWS recently bought Cloud9 IDE, and you can literally just use an IDE, a web IDE, paste Node.js code in, and get a functioning AWS Lambda, you know, route that's like listening onto the web and responding to requests in no time at all. You can do it with Go as well, but it's not as nice. I recommend a different form of deploying functions to AWS Lambda later on. And it's less labor intensive for your team because it's a managed service. And this is just true for, you know, any types of service. Managed services such as message queues or databases, where you're simply taking less time, less stress on your ops team because they don't have to directly be in front of, you know, something like, I don't know, any type of networking outages or whatever. That's a lot lower level. Now let's go on to the cons. So, you have little to no control over your infrastructure. That's what happens when you give it all up to a service provider. For example, on AWS Lambda, You can tweak your RAM and CPU in discrete chunks, but you can't tweak them independently. I believe I honestly don't even know if they have an official documentation saying exactly how much CPU you get for every, I think it is 64 megabytes of RAM that you provision per function, and you're not able to say if you have a function that requires a lot of CPU but not a lot of RAM, provision them in independent forms, which could be annoying. Also, 512 megabytes of disk space is a hard limit, so they want you to use AWS S3, basically. Allowing your functions to scale haphazardly can place strain on other parts of your system. This is true for all microservices, really, but Lambda, it's kind of further exacerbated because every single request, for example, would spawn off a new process. And if you aren't smart about managing your database connections in AWS Lambda specifically, you can simply have 50 requests came at the same time. Suddenly you have a lot of expensive database connections that, something like Postgres could have a hard time handling, AWS Lambda does have some basic concurrency limits, default concurrency limits, such as 1,000 lambdas at the same time, to kind of help you from shooting yourself in your own foot, basically. But you do have to keep in mind things like that. And the promise of not having to worry about infrastructure is not always upheld. Oh. Yeah, I'll go into that one later, because that's very relevant to this particular presentation. But right now, what exactly is AWS Lambda? So, the largest cloud provider, AWS, recently released, not kind of recently, 3 months ago or something, support for Go in their very own functions as a service platform, AWS Lambda. They're the only ones to support Go, not even Google Cloud Functions supports Go. Neither Azure Functions. I already went into this a little bit, but AWS Lambda essentially takes your Go binary that you upload to the cloud and runs it inside of a container that is essentially specialized to run on their platform. So AWS Lambda is smart and selective about spinning up containers. And this is kind of leads into the previous con that I was talking about, referring to AWS Lambda not having to worry about the infrastructure. But the fact of the matter is AWS Lambda doesn't want to constantly be running your code, able to receive requests at any time. So it's based under an event system where you take an abstract event and wake up your function and run the code, and then it's done. And hopefully your function takes a small amount of time to run. In fact, less than 300 seconds. That's the hard limit for how long your function can run using AWS Lambda. So AWS Lambda will spin up your binary in a container, but it will try to be smart because it will gauge how long it's been since the last request and essentially work out a plan on how long to keep up your container. So what this effectively means is you might think that AWS Lambda is spinning your function up in a new container every time, but you're not. You might have leftover trash in /temp files. You basically have to be aware of a little bit of the implementation details. But this leads back into what I was saying about database connections. AWS Lambda gives you a way to pass certain information between different invocations of your Lambda function. Therefore, you would be able to access things like database connections or whatever if you smartly pass it into the context of each function, which is just a regular Go context that you guys would already be familiar with using. Oh yeah, so a cold start is simply when a function hasn't been invoked in, I believe 15 minutes is like the, I don't know, maximum time, but they essentially have some type of algorithm that's trying to calculate exactly how long it is. And it's also at different levels where, you know, if it's been more than 15 minutes, it might take a full, 5 seconds for them to spin up their function on the first request. It hasn't been that bad for cases where I'm using it, but I've been seeing complaints about that. And also, if it's been, 5 minutes or something, you might see just 10 milliseconds or something, because AWS Lambda is just smart about keeping the same container if you're using it each time. But you do have to take advantage of that a bit. And more cons. So this is a bit of what I was talking about, where the cons of promises about having not to worry about the infrastructure is always upheld. I originally had a slide presentation where I was using a third-party API for my code, but what I found out is that AWS Lambda is essentially having a very small pool of IP addresses that it assigns to each function, and if a bad actor uses them for bad things, people are going to blacklist that IP. And you don't have any real control over that IP, so you're kind of just deploying a function to AWS Lambda repeatedly, hoping that you don't get a bad IP this time. And I decided to spare you guys from doing that, so yeah. But that's a case where the underlying infrastructure very much impeded me, and there was little I could do because I didn't have enough control. You can get around this by deploying your function in a AWS VPC. That gets a bit too deep into AWS specific talk though, so I'm just going to ignore that. Functions have a maximum time of 300 seconds. I think I already said that. But yeah, AWS Lambda is really geared towards small event-driven microservices that are kind of just doing a small action to a data and immediately dumping its result into, a database, S3, a file, something that it gets it, and it's done as quickly as possible. Hell, you can even intercept requests to other parts of your infrastructure. For example, you can use AWS to intercept a request to download a file in S3 and use that information to modify the file in transit. And that means that your function is now directly slowing down every user that requests that file. Like, the lifetime of 300 seconds makes sense because it's also regarding the philosophy of using AWS Lambda as a microservice and to simply reduce your functions down in size. But if you want to stubbornly just make some massive thing in AWS Lambda, then
question. So this runtime includes the warm-up or after? Because you said sometimes you might wait for the infrastructure to go from the cold to warm, yeah?
Okay, so yeah. Maybe I didn't explain it well enough, but there's cold start, which is completely spinning up this new container entirely. And then there's a warm start, which is the container is already up, so none of that time counts, so it's basically just running your function with the parameters passed in. So, for example, the first user might have a delay of 3 to 5 seconds, which really sucks, obviously. But everyone after that, will be fine. And there's a technique that, Java developers primarily were using with AWS Lambda, which is to simply set a event, essentially a cron job that sparks the AWS Lambda up every 5-10 minutes to simply keep it warm. Yeah.
So I assume you're not billing for the uptime of the container, right? Because the
execution. No. It's very tightly controlled, and AWS Lambda prints out in log statements exactly the seconds and the memory that you're paying for. So it's very informative that way. Yeah. Running Go on AWS Lambda history. Yeah, so you were able to run AWS on Lambda, Go on Lambda previously, way before AWS made it official. You simply would just pack the Go binary in a Node.js zip file and start a new process, and just kind of had it work. There eventually was a more complicated solution where people would write some really hacky Python code in C and just kind of directly call the Go binary. And there's a framework called Apex, and there's this other library I found, which is in the next slide. But you can basically just kind of take a look at the history of what people had to do to write Go on AWS Lambda, and be thankful that you don't have to do it now. But yeah. Yeah, so before Go was on AWS Lambda, Java and C# were your main options. And C# is supported on Azure Functions, and they are simply doing a better job in performance than Lambda. You know, surprise, surprise. So Java was kind of the main tool of use if you are, you know, liking statically typed languages and trying to write something in AWS Lambda. But Java, this is why I was mentioning that the Java programmers especially would be hitting there, warming up the AWS Lambda containers, you know, every 5 minutes or something, because Java would have the worst startup time out of any of the functions on AWS, you know, any of the other languages, which was Python, Node, C#, yeah, Java, that's pretty much it. But it had the best runtime after you accounted for a cold start. So yeah, Go was poised to kind of be a very nice middle ground where it's not going to be as heavy to start up. Therefore, you know, you don't have to pay for hitting a Lambda function every 5 minutes, which is nice.
What would be the reason that C# is slower?
I looked at there's an issue that I link in my references at the end, and you could kind of go through all of it, but yeah, I don't honestly know why. I assume that just Microsoft has better tricks if you're running it on Azure Functions, and it's not like it's bad or anything. If it's not super performance intensive, there's nothing stopping you from running it on AWS Lambda, but yeah, like there was basically some issues where people were complaining that they couldn't run C# on Lambda. It wouldn't fit their use case. And at the end of the day, the guy basically gave up and ran his own server instead. And the AWS guy didn't really have anything else to add to that issue, so I was like, it's not great. But yeah. I do have some links to corroborate some of the things I say at the end of this slide. Yeah, this is just pretty much what I said, but this is the direct link, AWS Go Shim. And there's also a framework, Apex, which even allows you to write Rust in AWS Lambda, which probably won't be getting officially supported anytime soon. So might have to take a look at that if you want to run Rust on. I think it works. I think there must be some solution for Azure Functions as well. So. And yeah, so now that AWS Lambda is fully behind Go, we can deploy an application in about 3 easy steps. So yeah, before I go into the code section, does anyone have any like questions generally about AWS Lambda, anything I said so far?
How about the cost?
The cost of running AWS Lambda? So it's actually very good because AWS has like I don't know the exact number, maybe it's like 100,000 or 1 million, but like free invocations each month, which means you can very easily get away with like not paying for specifically the AWS Lambda usage. And yeah, like I feel like they really get you by making it so that it's hard to call into AWS Lambda without using other AWS services, which, you know, you will have to pay for. But Lambda itself, very cheap. So yeah.
So this compare with Azure, because I know Azure has a kind of the same
I mean, I don't know what Azure's free policy is in terms of like how much invocations and seconds they give you for free each month. But yeah, Azure Functions is very comparable with AWS in terms of like, I don't know, performance and speed and all that. Anyone else? All right. some code. All right, so here is a very small
Can you make it bigger?
function. Let's see.
No, it's very small.
It's a big.
Uh-oh. Now it's too big. Let's see if we can find a happy middle ground here. There we go. Everyone can see that?
Delete that vertical white space.
It's just enough white spaces. No more, no less. Alright, so here's a very simple Lambda function that very much just takes in a bucket, scans the bucket, and outputs a list of files, and outputs the size of the bucket in bytes and the list of how many files are in that bucket. For some reason, AWS doesn't expose this function. So you would think they would, but they don't. So yeah. All I'm doing here is using the AWS SDK in Go and this new GitHub repository that AWS made, which is mostly just to give you an invocation point in to Lambda, but they also exposed another GitHub repo that has all of the events that AWS Lambda can send to your Go function. It's all strongly typed, so yada yada. But the SDK is, would be familiar if you've ever used AWS SDK in Go. So I'm creating a session, which is just a very convenient function that's essentially grabbing AWS credentials from wherever you can find them, environment, variable, home/.config or whatever, creating a session. With Lambda, your functions run using a AWS role, so you shouldn't even need to worry about the API keys and just be able to call this function without setting it up at all. And then just store a string which is the name of the bucket I'm going to scan. And yeah, call the S3 list objects v2, grab these objects back, scan through them, add them up. Very simple. To deploy this, I can just use this quick script. So I'm simply grabbing my dependencies, building it for Linux AMD 64. That's all you have to do to get a binary that'll run on AWS Lambda. AWS also exposes a Docker container called AWS SAM, which is the full environment that you can run your Lambda functions on, but just building it in this is more than good enough. And then you zip it up and send it off to Lambda. This is the role I was talking about before. What does I want to say? Yeah, one thing is, so yeah, I'm just telling it the runtime of Go1, the role, the zip file, and handler, which makes a lot more sense if you're using like Node.js or Python, because AWS actually listens to you and picks a handler from the code that you send up. But for Go, all handler is the name of the Go binary that's inside of your zip file. So what this effectively means is that you cannot create a single Go package that has multiple use cases, really. Like, you can't have one Go binary that can accept multiple events because it requires a main function. Yeah, it requires like main package, main function inside that. And all you can do is choose which file inside this .zip that you want to use. So yeah, let's just deploy this.
Is that a real role?
This is a real role, yeah.
Don't worry, it's being recorded and will be pushed to the internet.
A real role that will be deleted. Alright, so
have you hooked it up to an event yet, or is that?
So this is Hold your horses.
It's okay. It's very
So,
simple.
let me get to the right. Yeah. And then we'll just deploy it using the script. Hopefully this will work. AWS Lambda was not allowing me to create Lambda functions over the weekend, so well, that's great. Oh, it already exists. That's true. I was scared about not being able to use this, so I pre-created them. Well, we'll take a look at the update script, which is almost the exact same. If I can find my mouse. There we go. There we go. Okay. So yeah, I've deployed it to AWS Lambda. Now let's just head over to Lambda. And you can see Bucket Scanner, which is our little Lambda function that I deployed. So here's the GUI for AWS Lambda. You can ignore this stuff to the side. This is just the permissions that the Lambda function has to deploy to or to use. You're always going to want to give all of your Lambda functions the role of CloudWatch logs because you can see how much you're paying for. Might be some good information to know. And SNS is probably the best way to communicate to a Lambda function. It stands for Simple Notification Service. It's a service AWS uses to, you know, simply retry notifications to other parts of your architecture, and Lambda is a pretty good fit for that. And then over here you have all of the triggers you can use to attach something to a Lambda function. So right now there's nothing attached to this, and the only way to actually use this function would be to create a fake event up here and hit test. So we're going to do that and see if this even works. And it does. That's good. So yeah, this is what I'm talking about. The log output is here, but it probably makes more sense to take a look at what you'd see in the CloudWatch logs. If it shows up. There we go. It's a bit small, but you get the point. So it printed out file count 30, you know, size in bytes. And here is the build duration, 900 milliseconds, and memory size, which is, you know, I've only used 36 megabytes, but I'm paying for 128. So yeah, took almost a second to run something that basically just scanned a bucket and returned a file size. It's a bit much. What happens if I click test again right now? The time went down to 200 milliseconds, and that's what I'm talking about in terms of cold start, where the container is up, it's spinning, it's, you know. It seems like they have different degradations or whatever. Like, if I run it over and over again, you can see now the time has dropped down to 18 milliseconds because whatever, like, Lambda specific stuff that's directly between me and whatever events hitting it is completely out of the way. And yeah, if you are, you know, if you're very concerned about Lambda performance, you'll probably have to end up just hitting your Lambda function over and over again. But for most cases, this is just fine. Yeah, so let's take a look at some of the triggers that are possible. So SNS, which is already kind of what I went into, you basically just set a topic and your Lambda function can listen to any event that's got sent to it. S3 is probably the most useful. As I was saying before, you can use a Lambda function to sit in front of any S3 file and essentially intercept requests to it. So you can do something like resize an image dynamically depending on like each customer request or something like that, where you just have one file in the bucket, and every time they request it, you resize it on demand. You know, so you can do some real fancy stuff like that, and it saves you a bit more money because you don't have to store so many copies of an image directly in there. DynamoDB is AWS's own database. Nobody cares about that. Kinesis is like a nice streaming for streaming large amounts of data. I don't have a lot of knowledge about that, to be honest. Code commit. Nobody cares about that. Then CloudWatch logs and events. I just showed you logs, but this is useful. In fact, at Key4A, you can use this for, well, maybe not directly this, but essentially what I'm doing is we're scraping some IP lists for, actually this isn't directly linked to logs, but anyway, we're scraping an IP list, hosted third-party IP lists, and we are essentially grabbing an S3 file, diffing a file with the new IP lists that come in each time, and then adding those to a IP blacklist rule for our site, which just, you know, kind of runs every hour, and it's very, it's pretty easy to set up, and paying like nothing for it because all the implications are free. So yeah. Using AWS Lambda is kind of like what you would be using shell scripting for in a more, you know, local environment is just a good practice, I'd say. So
so it's
yeah.
not heavy enough that you can be like if you can't be bothered to like set up a whole container instance for
Exactly. Because yeah, like for something like that, it's like where would I have run that? I don't want to spin up a container for this thing that runs every, you know, let's say 6 hours or something. But I also don't really want to stick that in like a dev or staging or, you know, other machine that could be used for other purposes and could go down. So therefore, tossing it on AWS Lambda is just a good fit. CloudWatch Events. This is essentially cron. You can take a look at the configuration, but it's very much just allowing you to schedule something like, see, rate 1 minute, you know. So this is what you use to keep a function warm. And finally, the one we're going to be using, API Gateway. So this is what allows you to put a REST API in front of your AWS Lambda function. And they basically handle all of the hard parts of like, you know, having this REST API up, serving, and any types of, you know, scalability issues or whatever. And all your function acts as is the handler that is accepting, you know, the raw JSON, the string, and dealing with it. AWS does have some size limits though on incoming requests. They're like, I don't know, 6 megabytes or something. It's actually really small. Like, it's not great for handling large requests, but if you do something like upload the file to S3 first and then have AWS Lambda grab a link, then that would be fine. So yeah, this function is pretty useless as it is. It's not connected to any events whatsoever, and the only thing that can hit it is me hitting this test button. So it would be nice if this was a bit more useful and would actually be able to, say, receive requests from online. So let's see the changes that would be required. So this is our 2.0 version. We're using a bit better practices now. We are using an environment variable to grab the bucket to scan so it can be changed. And we are using an actual AWS event. So this is what I was talking about before. You see I'm importing the AWS Lambda Go events. Let me make this a bit bigger. AWS Lambda Go events repository. And I'm grabbing the API proxy requests and returning a response. This function here, this bucket scanner v2 function, is essentially in the same place as Lambda start was before for regular bucket scanner. The AWS Lambda essentially accepts a very wide template for. Actually, let me just show it to you because it's pretty easy. Yeah. AWS Lambda accepts a pretty wide variety of function signatures and even accepts a context, which is just a regular GoLang context. So that's what you would use to get any values you want from previous container invocations that have happened, recently. And yeah, so you can either return you must return an error if you return something.
So it's just by assigning key values to the context, and then you can
it's regular Go context, so it's like nothing more than that, really. And yeah, that's where you would store database connections, anything that you're worried.
So if you are storing database connections, won't that mean all of your Lambdas would use the same one?
So that means all of the Lambdas that are using that specific container. Because the way AWS Lambda works is if you have 10 requests that come all at the same time, they will spin up 10 different containers. It only reuses a container for an 11th request that came in after the first one ended. So
they're not used concurrently.
No, they're not running several of your functions within one container. It will spin up. Yeah, it will spin up a new one for each Lambda concurrently.
So how do you know what that number of containers is going to be?
It's
if you care about the number of database connections, for example.
Well, that is why I listed this as a con, because that number of containers is essentially limited to how many people are requesting your function at the same time. But you do have some control. Let me head back. Let me try to head back. You do have some control over how many simultaneous Lambda function containers are happening at the same time. That's what this concurrency value is. So every region has 1,000 simultaneous AWS Lambda containers that are available to you across all of your functions, which means if you had one function and 1,000 people requested at the same time, that 1,000 first person would fail their request because you have run out. And you actually have to manually ask AWS for some more. I don't know what the actual limit is, but everyone starts with 1,000.
Is that reserved concurrency, is that what it says?
Yeah,
you
so
keep things warm if you want.
No, that would be nice, but no. What this means is you can limit a single function to only accept, X amount of concurrent requests at the same time. So if you were worried about starting your database connections or whatever, you could just set this to 10, and you know that there will never be more than 10 at the same time.
No, I mean like below it says reserve concurrency.
That's what I'm talking about.
Okay, that you're
so when you hit reserve concurrency, you can put in a number here, which would be 10.
So you're saying that's actually a maximum, that's not?
That is how many concurrent Lambda functions you can have. So how many containers that can be spun up at the same time. They aren't going to take this number and then keep 10 up for you all the time. Would be nice, but no. They will, however, max out the amount of simultaneous containers you would have at the same time to whatever this number is. And this number is per function, right? So you can kind of divvy it up smartly so that, the database connection function would only have 10 and everything else can go wild.
So if you actually want to partition your 1,000 amongst your functions.
Exactly. You would definitely want to be using this.
Cool.
Yeah. I guess while we're down here, so yeah, you can set a timeout for your AWS function. You can set the megabytes and CPU, and here it says function is allocated CPU proportional to memory configured, which is a bit crappy, but well. Network VPCs. This allows you to run your Lambda function within a private VPC, which means, I'll just go this over super quickly, but it essentially would allow you to, say, have a Lambda function that can access your database, which could be in a private subnet, because, you're a good database admin and don't want your database to get accessed by randos, and you want your Lambda function to hit it. And that also allows you to, through some nasty configuring with AWS subnets and firewalls, restrict your outgoing Lambda request to a specific IP address, which would be how you would get around that IP thing I brought up earlier. It's not user-friendly, but you could do it. Any more questions?
What's that debugging? That sounds pretty cool.
This is AWS Xray, which is a service that I haven't really went into, but it's essentially them monitoring the hell out of your program by attaching hooks to, you know, CPU, memory, heap usage, blah blah blah, and porting that all to AWS CloudWatch. And yeah, so you know, another service you have to pay money for, which is why it's not there. But excuse me. But yeah, that's what that's there for. And it's actually, I'll go into this a bit more. It's actually pretty interesting because you can track a single request through multiple Lambdas by giving the request a unique ID, which means that you can use AWS Xray to track a single user's request, you know, no matter how far it is away from the first invocation. So you can identify where your in your environment is slow or whatever for whatever reason. But I haven't used it at all, so you know, can't really say much about it. Yeah.
So if you exceed the limit, let's say you reserve 10 and you fire off an 11, what happens? Do you get back like an error? Like, let's say you're making an HTTP request, are you going to get an error back, or is it just going to sit and wait until one is free and then?
I don't know. Let's find out. So if I set this to 1, and wait, no, this isn't gonna work. All right, I have to go to the next part of the presentation first. So we have upgraded our bucket scanner to a version 2 that accepts an API proxy request and receives a response, which means now it's vulnerable to some guy just hitting F5 many times. So we'll be able to test out the function, concurrent function thing. But I just want to go over the structure of this event. So yeah, you can see that it's basically, you know, it's a very simple map of string for queries, query parameters, path parameters, all of this. You can have your function accept all requests to, like, you know, just the root path of your URL and have it implement its own handler. But a smarter way of going about things would be to use API gateway to essentially route different paths to different Lambda functions. And you know, you can pass up like a Swagger 2.0 JSON document. I don't know if you guys are familiar with REST APIs, know about it, but you can formally describe your entire REST API and just have it worry about all of the request handling, and your Lambda functions purely implement the business logic. Since I only have one thing to care about here, it's pretty easy to implement, but that would be useful if I had a larger framework in mind. So yeah, now instead of just returning an error, I'm now returning an API gateway proxy response, which is, you know, status code int. That's pretty much it, nothing special. Oh yeah, one more thing. The quick-eyed among you might have noticed that body is a string, which is tying into the previous point of the body that your AWS Lambda function receives can be very big, because it's just kind of getting loaded all into memory. You're not going to be getting any nice reader or read closer objects. Yeah. But yeah, other than that, everything's pretty much the same. It also prints out the file count and size of a bucket, and it returns it in a little JSON function. So yeah, any questions about this?
So when you were talking about like assigning IDs, are you implying that like with the API gateway you can set up middleware and have it like flow through different like stages before it gets to your
Not exactly. I mean, not with API gateway, but yes with Lambda, where, you know, for example, you could have some request ID that, okay, so you could have an API gateway handling requests to a Lambda function that staples a request ID to that, which could be like a user ID or whatever, that then sends it to a simple notification service topic, which then kicks off some more Lambda functions, and those secondary Lambda functions would have that same request ID. So yeah, an Xray would be able to track all of that and identify that, hey, this third function subscribed to the topic is the slow one, that's what's slowing everyone else. Yeah. Anyone else have any questions about this? So, but this is just the raw code. We still have to actually deploy this thing. And anyone who has used AWS might have heard of AWS CloudFormation, which is a really nice way of just formally specifying exactly what your function needs, what it uses, and yeah, it's a lot better than rolling your own deployment scripts in like Python or whatever, which is kind of the standard, I guess, usually. But with this, all you need to do is formally specify what you need, and it will kind of figure out all the rest. So this is my preferred way of deploying to Lambda, and you should use it as well. It abstracts a lot of the pain points that you might have using just a regular shell script, where, you know, if, for example, as you can see, before when I deployed this didn't have any events, and if I wanted to add an event, I would have to write another, you know, shell function or whatever to attach the API gateway. But with this, all I have to do to attach the API gateway is to specify an event field. You know, call it something, this doesn't really matter, but the type is API, which says API gateway. I'm listening to all GET requests on this path. And, you know, this is kind of what I was talking about of using API gateway as your kind of handler. I could have many different functions here, all which could be listening to a different path. I could pass in the Swagger JSON document, which would formally specify my API and validate it if I needed to. API gateway is a really cool way of using AWS Lambda. And yeah, so GoLang-Lambda demo, that's the bucket that I pass in. And you can see here, reserved concurrent executions, which is that number I was changing, can be also defined here as well. Pretty much everything related to your function can be defined right here. So yeah, and the role. Although this role is actually not necessary, strictly necessary, AWS CloudFormation will auto-generate a role from guessing what you have access to that you've specified in this YAML document. So for example, it would auto-generate a function that has access to API gateway. It, however, would not auto-generate a function that has access to CloudWatch logs. So while it's a nice feature, you're probably still going to have to create your own role anyway. Yeah, anyone have any questions about CloudFormation? No? All right. So yeah, now we'll just run that script. So yeah, build it. Oh yeah, I didn't actually go into the script, but it's pretty much almost the exact same. Grabbing my dependencies, building it, spitting it out into a zip code. The only difference here is that I'm using a AWS CloudFormation as opposed to AWS Lambda as before, and I am packaging my Go code. The AWS Lambda CLI will nicely accept just a zip file from your computer, and you just don't have to worry about it. But once you start to get a bit more heavy into it, AWS forces you to upload a file onto S3. So, yeah, package is simply taking my local zip file and uploading it to S3. It's kind of how AWS gets you with all the little hooks to all the other parts of its ecosystem. But S3 is very much cheaper. Yeah, so did that finish? Yeah, CloudFormation takes a bit more time to deploy to, but it is worth using in terms of the ability it gives you to abstract away a lot of the hassles with remembering deployments, you know, committing your things to source control. So yeah, now we are on the Lambda function. So as you can see, it now listens to API Gateway automatically. Don't have to set it up. And if we just go here, find out the user-friendly URL that AWS Lambda gave me. I can invoke the function. And there we go. Now we have a tiny API that, you know, very little code, and I'm able to basically abstract away a lot of the headaches with hosting my own server with very little cost.
You can spam it down.
I don't actually know what's going to happen if I spam a bunch of people, because it's just me, right? And I don't know if I can like slap this open to someone else. Maybe if I open it up in separate tabs.
I think you've got 2 instances of Lambda still. Because you're,
Right, yeah, reduce it to 1.
Working on the loop and curl it.
Yeah, maybe I'll have to do that. Can't scroll down past
Get
this.
2 terminals curling it at the same time. Put it into a patchy benchmark.
It's a tough crowd. We all just want you to break here.
Well, to be fair, it's fairly easy to break, so you're not exactly.
I just want to know what status code you did that.
Okay. Oops.
Oh.
Let's see. Did I copy and paste that? Yeah. My curl is not very good. Okay, so that. Masterful coding right here, right now, folks. Can't miss it for the world. This will probably work. Internal server error. That's what you get. You get a 500.
That's lame.
Well, thank you. All right, so yeah, that's pretty much the easy bucket scanner implementation. And then just for fun, I created a third function that does something a bit more interesting. So I don't know if you guys have known about Netflix's Chaos Monkey, which essentially randomly takes down servers during production and, you know, keeps their programmers on their toes, essentially, by testing their failures, testing how they respond to infrastructure failure. I have a very mild function that doesn't do anything close to that, but it randomly deletes a file from an S3 bucket, which, you know, is basically almost the same thing. And it pings a notifier, you know, the supposed victim who has to clean up your mess. And it's exposed as an API gateway route, so really anyone can hit it, which is a terrible idea. Yeah. We're going to look through it anyway. So, yeah, you can see I'm importing a couple more things here, mostly just SNS. And, you know, you're setting up an SNS region. SNS is only available in like 3 or 4 regions, so you have to specify it a bit. Using SNS publish to send a text message to victim's phone. It's actually really easy to use. This is pretty much the entirety of it. Just message, phone number, bam. And then we have Chaos Chimp. This is kind of what I was getting into in terms of validation. So for example, right here, I have the function fail if phone number isn't provided. But I could have API gateway essentially check it before it reaches my function, which would save me money because my Lambda wouldn't even run. Although you do have to pay for API gateway, so I'm not too sure about the balance there. Yeah, so then I list the objects again. If all the objects are already deleted, you know, I mean, someone just allowed this entire bucket to get empty, which is probably not a good thing. I randomly select one of the objects from the buckets, notify the victim about it, and then I delete the object. I notify them before deleting it, so that even if it fails to delete, you know, you still gotta keep them on their toes, man. You know, give them a little heart attack or something. Yeah, and then I send the response back, and that's pretty much it. It's pretty similar to the bucket scanner, really. Any questions about anything?
Is it actually going to send text messages?
Let's find out. So, and I guess I'll go over the cloud formation, but it's pretty much the exact same. I just have different environment variables. Yeah. Deploy chaos. So, yep. Now we chat a bit while we wait for CloudFormation to deploy. How's it going?
It's going to use SNS to send the message?
Yeah.
And how much does SNS cost?
Well, I'm pretty sure I'm in the free tier, so it's fine. It's not really my work. And we're waiting for stack, create/update. But this should happen soon enough.
Can you get the weather in Seattle while you're waiting?
Yeah? No. Alright. Chaos Chimp Lambda. Pretty much the exact same. Let me figure out where AWS has hosted us. We have yeah, obviously these URLs are extremely ugly, but you can just change them to whatever you want, or have something that redirects to this, so it would be fun. So yeah, anyone wants to side quest it? Nobody? Just me? Alright, that's fine. Let's see if this actually works. There we go. Chaos has been created. And I get a text message that simply says, uh-oh, something happens to production.config/all of the passwords.txt. It's not great.
That's actually probably good.
Yeah, you're right. Why are you storing all of your passwords in a .txt file?
In S3.
In a public bucket. Really just, you know, I might have just hit T-Mobile Austria.
So if you complain to your cell phone provider now about getting unsolicited text messages, what do you think is going to happen?
Yeah, I don't know, because this is very clearly a very nice file. AWS does have some restrictions on the amount you can send, but you know, by the fact that, say, a lot of AWS Lambda IP addresses are being blacklisted, you can kind of tell the activity some people are getting up to using AWS Lambda. So, yeah. I wouldn't be surprised if you use SMS, that maybe some of the text messages would get blocked by providers, right? But there is Actually, you know it won't, because every time I deploy to CloudFormation, I'm sending up a zip of the file. So one would have gotten deleted, but when I deployed Chaos Chimp, one would have gotten added. Although I deployed Bucket Scanner too as well, so really we should be seeing one more.
We'll run Bucket Scanner and then run the deleter again.
Well, it also printed your file like total size.
But they're different. They're different stacks, though, right?
Different stacks, yeah. Each new stack would have its
Oh, I
own
see.
deployment. Where is API?
I believe you mentioned something about a streaming input service too.
Yeah, Kinesis.
How does that work? Is it a push model for a stream, or because if the function is not running for whatever amount of time it shuts
Yeah,
down? So
yeah,
how does
the-
it receive new updates?
Yeah, like, I honestly don't know a lot about AWS Kinesis, but it's basically just another event-based systems where you can have it react on a stream starting, and the use case would be to kind of do some transform operation to that stream for, you know, the length of time that stream is coming in, and, you know, send it somewhere else or do whatever. All right, let's see if we're just full of eyes here. So, anyone else want to sacrifice their phone number? No? No?
519 501 1022.
509
519
519 5
01 1022.
1022.
We've got so much spam.
Chaos has been created. Gonna have to let you.
Yes, it has.
We're going to-
API keys.txt is good.
God damn it. That'll be hard to clean up. And what do we got here? 30 files. The size didn't decrease because that file is actually 0 bytes. But it's fine. So yeah. That's pretty much my whole presentation. So I hope you guys learned something. Cool.
Now I'm curious what other collection of dummy file names you have in
I can't show you them because my laptop just died. So that was a very,
Good timing.
very nice time.
You didn't
I
have
had,
to get your, you didn't get to show us all your VS Code plugins for AWS.
I could have. Well, I didn't have any for AWS. It's just like
Yeah.
MongoDB. But yeah, I had all of the SSH keys. I had all of the backup.zip because, you know, just kind of zip them up there. And what else do I have? I think that was it.
You made a comment about DynamoDB.
Yeah.
You were facetious, or you know more than?
You know, DynamoDB is probably a useful tool if you are already entrenched into the AWS ecosystem, but I don't know if I would want to use it if I was outside of it. That's all I was really saying. You know, if you use it for your day-to-day, sorry for offending, but it has a generous free tier, which is kind of the only reason I looked at it. Which was that, yeah, it's, you know, allows you to store a lot of data for free for like, I don't know, first month or whatever. But yeah, I haven't used it, so.
Does it support anybody else's APIs or just its own?
Whatever AWS has.
Yeah, it's not like, see,
I like
Cosmos DB is actually nice with Azure because it supports MongoDB's API and it supports Cassandra's, Apache Cassandra's API. So you actually could just, move over to that. It even supports SQL for some reason, even though it's actually a NoSQL database. They just kind of finagle it somehow. But yeah,
Yeah, you're right. Like, if you use AWS, then Dynamo isn't a bad tool. It actually works fairly well.
yeah.
But, yeah.
Would you use it outside?
Yeah, it's not working.
Yeah. Yeah.
So you ever use serverless.com to abstract away this?
So yeah. I was thinking about doing that in this presentation, but I decided against it since Go only runs on AWS Lambda, so there's no real point in abstracting away the provider when there's only one. kind of an unnecessary abstraction, but hopefully Azure will provide it in the future. Google Cloud Functions is not even out of beta yet, so I don't know about holding your breath for them to like support Go anytime soon, but I figure Azure would probably support it sooner than G-Cloud for some reason.
Odd, given it's Google.
Yeah, it's pretty strange actually, but yeah. All right.
So we don't have a presenter yet for May. Anyone inspired by Daniel's presentation?
Let
Does anybody want to